Hi everyone. In office hours today, I think we came up with a really good way to conceptualize S molar solubility. So I know that office hours are meant for me to answer your questions, but in this case, it really gave me a chance to figure out a better way to teach a concept. And let me show you what we came up with. They say the KSP of copper phosphate is 4.77 times 10 to the minus 18, and the molar mass is 285.61 grams per mole. Calculate the molar solubility, and the solubility is in grams per liter. Actually, the molar solubility is in molarity, and it's represented by big S, and we have molarity, and this is represented by S, and like it says up here, it's represented, or the units are grams per liter. Okay, that's not new. Writing the chemical reaction is not new. We have copper 3PO4. Everyone should be able to do this. Solid goes to 3 copper plus 1 phosphate. And phosphate we know has a 3 minus charge. Copper is a variable charged metal, so based off of this, we need 3 copper ions for every 1 phosphate ion. So that means that copper is plus 1. Okay, that's not new. What is new, and what we did in office hours, was we conceptualized S as the amount of salt that is dissolved, that ionizes. So for instance, if we have 1 molar copper 1 phosphate and 0.8, no, this, yep, 0.8 is dissolved, well, we're going to minus 0.8 from the 1 molar. But what about the ion amounts? If 1 molecule of copper 1 phosphate gives me 3 copper ions, then if I lose 0.8 molar, that means I will gain 3 times 0.8 molar. So we're just carrying the coefficient, and we're putting a plus sign there. And we're gaining one ion of phosphate for every 1 molecule of copper 1 phosphate we lose. And using our numbers, if this was 0.8 molar, then we get 0.8 molar of phosphate, and that's an S. So I think the new way to think about it is this is minus S, okay? And that's why you have plus S plus S. Now these are the concentrations now in terms of S. We're given a KSP, and in terms of the steps, this is the first step. The second step is to write your expression, because we want to make sure that we hit all the required exponents. That's cubed, and this is, there's no exponent, it's 1. Oh, and put 3 minus. Okay, now what are we doing? Well, this equals 4.77 times 10 to the minus 18. You're going to input for the concentrations these two terms. 3s goes in there, and s goes in there. Don't use brackets, don't use square brackets, right? Because now we do have our concentration. It's just in the terms of s. 3s cubed, okay, and s. And that equals this number here. Now we solve for s. You're going to cube the 3 and the s because those two are in parentheses. So 3 times 3 times 3 is 27. S cubed times s. And that equals 27 s raised to the 4th power. Right? Equals 4.77 times 10 to the minus 18. Now in terms of the calculator work, let me get this number into my calculator. It's minus 18. Okay, that's saved. I'll divide both sides by 27, so divide by 27. Okay, so that number's saved. And what I do with this, I'm not sure what it's called in math, but we're going to take that, and the answer. Okay, let's put it in scientific notation. S equals 2.05 times 10 to the minus 5 molarity. Okay. What does that mean? If I have 1 molar of this originally, then 2.05 times 10 to the minus 5 molar will dissolve. That is molar solubility. And then when that amount dissolves, do you see how we get 3 times that amount of the copper plus ion? And we also get that amount of the phosphate. All right, so that is molar solubility. And simply to go to solubility in grams per liter, we are just using dimensional analysis. We are just using unit canceling. And we'll break this up into moles per liter times, now I need grams on top and moles on the bottom, right? 285.61 1 equals. Your moles cancel out, and we get grams per liter, which is the units for solubility up here. I have that number saved, times 285.61. Okay, now what does this number mean? 5.86 times 10 to the minus 3 grams per liter. If you have a liter of water, that equals little s. When you have a liter of water, you could dissolve this many grams of the copper 1 phosphate. Okay, when you study this, yes, do this technique, solve for big S, solve for little s, but also have in mind, well, what does that literally mean? You could go into the lab, right? And you could go into the lab and weigh out this amount of the salt, and all of that salt should be soluble in 1 liter of water. Now, if you go above this amount, let's say you try to dissolve 9.86 times 10 to the minus 3, you will have a precipitate. It will settle out to the bottom. All right? That's all I wanted to say. Again, I'm advocating come to office hours mainly for selfish reasons. It helps me improve the way I teach some of these concepts. And probably for next year, I'll remake that video where I talk about S molar solubility and incorporate this example.